This is a video on solving systems of equations using graphing and substitution. In the next video, we'll do elimination, but for this one, solving using these two methods. So a system of equations is two or more equations. So anytime you have two or more equations and you're solving them, that is called a system of equations. There are several ways to solve a system of equations, but the three ways I'm going to show you are by graphing, substitution, and elimination. Graphing can be done using a calculator. You go to y equals, you hit graph, and then you can use the calculator functions to locate their intersection, or you can do it by hand. I would recommend the calculator because it is more exact, but we can sketch it by hand and get an idea of what that looks like, and then I'll show you on the calculator. So let me just review. It does say use a calculator, and I will, but let me just review you a little bit on graphing. Draw a straight line here so we can draw a graph. This is my x-axis and my y-axis. My first line is y equals 2x. It does not have a y-intercept, or rather a y-intercept of 0, and then a slope of up 2 over 1. Then I'm going to draw a line through those 2 points. It's pretty close. You can see how drawing it by hand might cause an issue. And then the next one starts at 1 and goes up 3 over 1. So by hand it's a little hard to tell. I was hoping it would be a little easier. Whoops. You can see why I am having trouble graphing it by hand. So you can kind of see why graphing maybe isn't my favorite method. Let's look at the calculator. So I'm going to go to y equals. In y1, I'm going to type 2x. In y2, I'm going to type 3x plus 1. Save those. Go to the graph. You can see that my sketch is close. So I have a blue line and a red line here. Those represent the two different linear equations. And then you can see down in the bottom left corner that they are intersecting. So my sketch is close, but it's really hard to tell. And that's why it's nice to use the calculator. So for this calculator, I'm going to double tap, find intersection, and up at the top left corner, you can see it says x equals -1, and then you see two -2's. So what that's saying is that on the red line, it's at -2, and also on the blue line, it's -2. So this is a point of intersection. This is where the two lines are the same. I could look at the table to confirm that. You can see at -1, the y values are the same. And if you look at the other y values, none of them overlap like these do. So this is the only place where the linear equations are the same. That is right here, -1, -2. So the solution to this system is a point, and that point is where the lines intersect. That's how you solve graphically. Graphing is not my favorite because you can see with the sketch it's not exact. Also, if you use a calculator and they intersect at a fraction, it's really hard to tell where that is. So I really prefer to do it algebraically. When you solve a system of equations, you're looking for the point at which the two equations intersect. And we can find that point algebraically. One of the methods to find it is called substitution. And so this is just a different method to find the same answer. Substitution is ideal when one of the variables is already isolated. However, you can still use it if one of the variables is not isolated. It's just this is ideal when it is isolated. So there's 3 methods I'm going to teach you, and you can choose which method you want. Substitution is ideal when the variable is already isolated. So for example, number 2 here, we have those same equations that we were dealing with before. It says y equals 2x. So y is isolated. And then y equals 3x plus 1. So y is isolated. If y is y, they're the same letter, then I can substitute. So if you think about a football game and 2 people play the quarterback position, then when one quarterback is tired or hurt, then you can substitute the other quarterback in its place. So what I'm saying here is I can take this expression and sub it in for that y, because y equals 3x plus 1. So I can say 3x plus 1 equals 2x. This was y. I'm just subbing it in. And then you can solve it. So I'm going to minus 2x. We get 1x plus 1 equals 0. Then we're going to subtract 1 to move it away. And we get x equals negative 1. I am not finished. I have found the x coordinate of my point. So now I'm going to take that and plug it into either equation. It does not matter. I'm just going to use the first one. And there's the y coordinate. So I write my answer as a point. And that does matter. The order matters, and it matters that it's a point because the 2 lines intersect at a point. Here's another example, number 3, solve using substitution. Now in the homework, it may say solve using substitution. If you know, once you learn elimination, if you prefer to use elimination, that is up to you. But this is just trying to get you to practice using one method. So we're going to do that. We do have y equals 6x minus 11. And then we have negative 2x minus 3y equals negative 7. So we're using substitution because we do have an isolated variable. Which means that I can take this and plug it in for y, because y equals that stuff. So I'm going to take that stuff and I'm going to sub it in to there. So I have negative 2x, I don't touch that, minus 3, I don't touch that, and then this is where I am going to sub in the y value stuff. So the green highlighting here got subbed in for the green y there, and that's why it's green. I'm hoping that the color will help you see that I subbed it in. You'll notice when I subbed it in that I used parentheses, because I'm taking all of this stuff and I'm subbing it in. And what's going to happen here is I have this -3 outside that I'm going to need to distribute. So the parentheses is important. So we have -2x minus 18x plus 33. These are on the same side, so I'm going to join those together. Then I'm going to solve for x. And I'm running out of room. Divide is the last step. So x equals 2. I'm circling that because I'm not done. I'm close, but not done. We know that y equals 6x minus 11. We also know that x is 2. So we can simplify that, and we get 1. I have these two pieces that now form the point where these two lines intersect, and the order does matter. X goes first, x comma y. And that is substitution. Hope you enjoyed. If you have any questions, please email me. I'd be happy to answer, and I will see you in the next one.